Господа,
Hi, everyone.
guys,
Hello.
gentlemen,
Hi, everyone.
welcome to
Hi.
our second talk for the day. I just introduced you all, so you can start your discussion, please.
The introduction was really flattering. Thank you. Hi, Titus.
Especially
Nice
for
to
me.
see you.
Hi, thanks for having me.
So, how's the weather
It's an
like
honor.
in the place you are?
It is kind of dreary and gray here in New York, but we are just coming off of a unseasonably hot week. So we had a number of days where people are out in shorts. Pretty unusual for November. So, yeah, it's not so bad.
Good, good.
And for you, Sergey?
Well, you mean weather? It's rather nasty here. About, well, 1 or 2 centigrade. And
By
dark.
the way, I think we should establish some kind of a code name because we're both Sergey. So I would suggest like the guy with the beard, but let's call you.
The big beard and the small
Let's
beard,
call you
okay?
Sergey. Yeah, it's not hurting my ego at all.
Nice, nice.
You both have me beat by quite a bit. So,
Okay. So we start the technical discussion.
Okay.
certainly.
Hopefully it will be technical.
Mostly.
Yeah. So I guess it's not a big surprise that we'll start our discussion with your latest activities. So for the past, I don't know, year probably, every talk I heard from you, I read the paper on the ABI compatibility. So can you please, if it's possible, to explain in words without a whiteboard, what is your suggestion there?
Yeah, so a little bit about ABI, which is Application Binary Interface. This is effectively the non-standard but sort of agreed upon protocol for how a compiler is going to represent functions that you might link in a separate library, a DLL, an SO, as well as the basic instruction level mechanics for parameter passing, like what things are going to be in registers, what the offsets of things are, the sizes of elements if you're marshaling data into memory. And it turns out that ABI sort of underpins a lot of, I think, fairly interesting and fairly important questions in the C++ ecosystem as a whole. Practically speaking, for Linux systems in particular, for anything GCC based, other than a break in the representation for std string in C++ 11, we have gone to great lengths at the standards committee level and at the implementer level to ensure that any code that you built in the past will continue to link without rebuilding going forward. And so for a lot of platforms, like I said, Linux, you have, at this point, most of a decade of backwards compatibility. Under Windows and MSVC, it's a little bit less than that. It's probably something like 5 years, maybe a little bit more. But increasingly over the years that I was chairing Library Evolution, a lot of questions came up in terms of, we would like to change this interface, or we would like to change the behavior for a given type. And in scenarios where that had any implication on the ABI, we would get a lot of pushback from implementers, and perhaps rightly so, saying that, it's a really bad experience for users if we break the ABI, if we break this backwards compatibility. At the same time, especially with the optimization and efficiency research that we've done at Google internally and papers that were coming through Library Evolution, there's kind of a growing list of understandings of the things that we're paying in order to have that backwards compatibility feature. And so at this point, my estimate is that depending on your workload, obviously, depending on like what things you rely on, I think it's fairly possible that a lot of companies, if you're using only the standard library, you might be paying as much as 5 or 10% performance overhead for using standard library types and standard library facilities instead of similar or equivalent things that were built in the modern era specifically for optimization, but that are not ABI compatible with whatever we happened to ship in the standard library 10 years ago. And this, I think, is sort of the existential crux for C++. It's this question of what are we going to prioritize? And it's a question of, are we prioritizing the backwards compatibility that we have not explicitly promised, but have sort of implicitly given to everyone for the last 10 years? Or are we prioritizing performance? Like, what is the role of the standard library? And I published some papers on this. I was trying to get the committee to address this question, to make a decision for at least a year. And in the last in-person meeting in Prague, we had a big plenary discussion, not quite plenary discussion, but a large discussion. A significant fraction of the committee was there on the question of, after Prague, like, we're going to start working on C++ 23. Is C++ 23 going to be an ABI break? And if not, are we ever going to do this? Because, if you've heard any other talks from me, like I talk about Hiram's law, talk about if you leave something stable for long enough, people depend on it. And there's hundreds, thousands, probably millions of places that people are depending on the ABI without necessarily knowing that they are. And so the question for the committee became, are we going to ask people to recompile in order to adopt C++ 23 or not? And if not, can we still argue that the standard library is prioritizing performance in any reasonable sense? And the result of that discussion was mixed at best. We said pretty convincingly that we're not going to do that in C++ 23. With my experience with Hiram's law and what the cost of change actually looks like, I think 23 may have already been too late. 26 is definitely too late. And so the upshot to my mind is the committee is never going to intentionally break ABI. And this means if performance is the thing that matters, you should probably be willing to hunt for something like Folly or Abseil or Boost that is going to give you a different, set of trade-offs with respect to performance versus stability.
Thank you, Titus. But ABI isn't mentioned in the C++ standard at all. So what exactly do you suggest? You are being bombed.
Yeah, I am a little bit. You're right. The ABI is not actually part of the standard. It is entirely the realm of the implementation, right? And this is why there isn't one standard ABI for that matter, right? It's a different ABI on Windows than it is on Linux. GCC and Clang have a tendency to collaborate a lot in order to make sure that the two basically produce compatible binaries. But like, it isn't a thing that the standard technically governs. At the same time, I spent years keeping a list of all of the things where we said, no, we're not going to do that because it's an ABI break. So the committee is taking ABI concerns as effectively a veto. Like, no, we're just not going to go down that path. And so we're in this very weird place, right? Like, we can't force the implementers to do things, but the implementers are forcing the committee to not do things. And this is an awkward sort of position to be in. I'm not sure that the committee necessarily has the ability to force the implementers to do any of that. So maybe this is just the sensible position, and like the only result we really have there is being aware of the position that we're actually in. But there's a lot to understand and chew on that comes as a result of both the thinking and the voting.
And how did committee react? So you didn't sound happy when you spoke about browsing.
Right. I don't think it's necessarily the wrong choice. Like, I think it is very reasonable to want to prioritize like making things easy for users, and for a lot of groups, saying something like, this is 5% less efficient than it would be like in an ideal world isn't the end of the world, right? Like 5%, okay, whatever. But for, very large tech companies like Google, 5%, like we're talking, some significant resources, talking large clusters. And that's a significant investment. I think so the Prague result was, I think formally the Prague result was not now, maybe later, we'll continue to consider things. But given all of the effort, all of the argument, all of the pushing, like we're never going to be more ready for it. We're never going to understand it much deeper than we did at that point. And the problem of everything that has come to depend on it, and since the last time that we broke it, that's not going to get any better on it. Like when we just leave it alone for another 3 years. So, practically speaking, like my belief is the standard library is never going to intentionally do this. At least not until there's a horrific security problem or something. Like I think it is lucky that we have not encountered a like Spectre or Meltdown, like speculative execution sort of vulnerability that requires a recompilation just to change, function call handling, things like that, because it's been close. And at the point that we force everyone to do this in a panic, like that's going to be unfortunate, because then we force everyone to do it in a panic one time, and we didn't plan for it, and we aren't going to be able to recoup the benefits of like, oh, while we're doing this, let's also fix all of these other dozens of things that are slightly wrong. So like, I've been pushing in years past, before the ABI thing became what I was focusing on, like I've been pushing for the committee needs the ability to fix mistakes, to upgrade things that have already been deployed, to change things that have already happened. And currently the model is you can tag things deprecated, sort of. Sometimes we remove it, but it's a little ad hoc whether or not we do that for any particular reason. And otherwise, everything that we ever want to change is purely through addition. And it is hard to fix things through addition.
Yeah.
And when we're thinking about a language that's already been around for 30 years, 35 years, looking forward to the next couple decades of every mistake we've ever made will be hanging around. Like that's a tough pill to swallow, I think. So practically speaking, the Prague decision made me realize that for my internal purposes, like I'm not comfortable recommending that Google broadly adopts a lot of the big things out of the standard library, like the small things that can't be done anywhere else, atomics, atomic ref, like stuff like that. Like, yes, these are good changes. The big, complicated facilities that are going into the standard library for C++20, this seems like a risk, and I think we would probably be better off implementing our own rather than relying on the standard, because templates, like every compilation of a template is name mangling and ABI impacting, and like you can't change any of these things after the fact, and that sounds like a big risk to me. So I anticipate that the standard will become known as a place to go for a good first approximation, and for code that needs to be very, very low level or very common. But for actual performance reasons, you'll need something else. You'll need, a Folly or an Abseil or a Boost.
So it's basically the current state, right?
I mean, I think that is the current state. Yeah. I think
I never heard
that
on just if you ask people from Google, Yandex, Facebook, Twitter, if they use like standard library, they usually use their own implementation of a lot of different stuff, but starting from string, ending with containers. Like, well, not a good example, but still, yeah.
Right. Well, and we're even finding like there's some meaningful overhead in string and containers, and things that are hard to change unless you actually control all of it. And this is going to be an unfortunate mess. Like it is a really hard problem. Like I keep saying, I don't think that the committee is necessarily making the wrong decision there. It does make a lot more work for groups that care about performance a lot.
Thank you.
So don't you think that adopting some ABI standard will slow down the new language standards adoption if we keep breaking the ABI with every new version?
Perhaps. It certainly adds some difficulty in adopting things. It certainly makes it more complicated to move from one version to another. But that said, a thing that I say pretty regularly, if you have a rare event that is very, very costly, you have two options, right? The option that most people go to out of fear is to try to make it even rarer. And the option that's usually better for engineering is to try to make it less costly. Because if it's important enough, you will find additional reasons to do it. And if it stops being a thing that you need to worry about, you can just do it cheaply, freely, constantly. Like C++ is currently basically proud of itself for having a 3-year release cycle. My other big project right now is the SWE book, and all of the research in DevOps and software engineering practice should be aiming for continuous delivery. A release cadence of every 3 years is not exactly something to be proud of. It's okay, but it's not great. Better than every 10 years.
Well, I guess it's still always a trade-off. I mean, we do have a standard.
I think we lost a small beard.
Yep. Sergey, could you please repeat your question? Hello?
Nope.
Seems like Sergey somewhat disconnected. So can you tell me, please, is this paper an official Google position?
Which paper?
Your
The
proposal
ABI?
for, yeah, the ABI proposal.
I don't know what that means. Google does not really have, like, Google's participation in the standards process is not one of Google has a position. Google sends many experts, and we trust those experts to have their own opinions and directions. And there were Googlers that voted against making 23 an ABI break. We are not a hive mind. I believe that the paper probably does represent what most of us think would be best, at least for Google, and that it's not just as the vote that we did get might be the right answer. The vote that we hoped for also might be the right answer. It really depends on what we're optimizing.
Okay, so if talking about Google's position is that Google does have a single opinion, that has lots of experts that have their own opinions. Do you think that most of Google's experts support your point of view?
Generally, yeah. Partly, I work closely with Chandler and Richard Smith, and they might people that do optimization and language and library design and all of these things. And like we don't require everyone to have the same belief, but I've had a lot of these discussions, and like our consensus for the things that seems to matter to us, the ways that we would evaluate the trade-offs. I think most Google people would tend to agree, like that we should either do it as soon as possible, or we should promise that we're not going to do it.
So I guess you know a lot of experts from other big companies. Do you know of some big companies that also approve of the paper, or experts from big companies?
I've had a lot of informal talks with a lot of people. I'm not going to put anyone on blast to say like that, X person from Y company specifically, says this thing. Like, I think there's, yeah.
Okay, so again, back to the standardization process. How do you think it will affect? Like we decided that it will slow down the process, but what changes needs to be done if a committee will decide to go this way?
So, if the committee decides that, say, C++ 26 is going to be an ABI break, then they need to make that decision as early as possible to make sure that the community and the implementers can plan for it. This is itself challenging. One of the suggestions in the paper was part of our understanding of the cost and user frustration for this is based on the sort of weak ABI break that was involved in the C++ 11 std string change, wherein the behavior of string changed and the name mangling changed a little bit, but all of the rest of the standard library and C++ code everywhere continued to have the same mangling and the same behavior. And So it's just a matter of if you have strings that are passing through interfaces that might have been compiled in two different translation units, or you have types that contain strings that are passing through such interfaces. And that's where it starts to get real messy. The paper, like my proposal is specifically that this is really hard because users can't reason about that without knowing all of the details of what is ABI, what changed, what things are going to be compatible, what aren't. And we did a lot of the Clang and GCC and lib C++ and libstd C++ folks did a lot of work to try to sort of patch it in a way that like hid that there was a break there, and that in many cases it would work and you wouldn't get bit by it. And then this means that in the handful of cases where those patches and half measures don't apply, like you're just in trouble, right? And there's no rhyme or reason to it from a user's perspective. Whereas what I was arguing for is, from a user's perspective, it's going to be vastly easier if you simply change like the mangling, you change the compiled representation for everything. And so code built in C++ 23 mode does not mix with code built in C++ 20 mode. That forces a lot of recompilation, obviously. Forces like you hold two different versions of all your compiled objects. But the rules are very simple, right? It is much easier for a user to understand what is and isn't going to work under that model. So if the committee was going to actually go down this path, we need to warn everyone, prep the implementers, make sure that we gather up all of the things that are useful to change at once, and then try to plan ahead so that it's not so painful the next time. One of the big issues here is the ABI is in many respects like a network protocol or a serialization protocol. It's like a file format. And in all of these things, you normally find a version number, right? Like you get in your network protocols, this is HTTP 1.1. You get in your like JPEG headers, this is JPEG version whatever, right? So that you have instructions for how to interpret the following series of bits. And the ABI currently doesn't have that. And so everything, like the first time that we make any change, it's going to be a big deal because you have to make a big change in order to even just add a version number. I kind of just don't see that the committee's going to do all of that. So I think it's easier to assume ABI is actually stable, and for performance concerns, go somewhere else.
A minute for the advertisement. We will have the talk on this conference about annotating ELF files. So if you want to add some meta information to binaries, and it's done by extension of Clang, as far as I recall. So you basically can, it's open source library, they can help you to add some meta information like versions, or probably some tags. And we have a question from our chat about mangling. So I will just read this because it's English. So can this be made better by mangling the structure of types? Say I compile against a copy and write string, and you compile against a small buffer optimization string, and there are no inline namespaces. Both are named std_string, but what if my object also has the mapping std_string is a bunch of pointers, and yours says that std_string is a small buffer. So will it be a problem? So basically a structural mangling to prevent linking incompatibility in. Sorry, my tongue is. Yeah, thank you. Sorry.
Yeah, so I think that could work, but I think in practice that's going to be pretty similar to adding a version number, or doing a, or an all or nothing change, because in order to, if you do that simply, like, oh, actually, it's not clear. Because one of the ways that this gets really complicated is when you have types that are nested many levels. So for instance, I may have a struct that has struct in it and a string or a pointer to a string for that matter. And the translation units that are building in one mode like may or may not know whether or not string is copy on write or small string. And this is effectively going to be like you're going to have two versions of every type, at which point, like, okay, you just have, you have a version number in there effectively. It's just not being called that. And this is what I found more than anything else is there are a lot of sort of simple things that you could do that handle the simple case of here's a function that's returning a value, or here's a type that contains a type that we're changing. Actually, returning a value is a bad example, specifically because you may not actually have the return values present in your function signatures. But yeah, like the quick answer to is this going to work or not really comes down to you have to nest these things several levels and then imagine that like you're dealing with translation units that were built in different modes and do these things linked together. And that's tricky at best. I can't hear you.
That's my Zoom problem. I start to speak being muted. There is another question from our chat. I will read it out loud. So ABI spec is not a language feature. It's either a compiler or a platform specification. If so, can we break an ABI compatibility, for example, CLang, and leave it as it is in GCC? If it's not a platform or compiler feature, then MSVC has produced binaries compatible with GCCs, one, and so on. Could you please elaborate on that?
I mean, yes, we can. It's a question of what you'll be able to link against. Like, if people want to have a pre-installed SO or DLL that has the binary contents of whatever library you're trying to link against, Boost or the standard library or any number of like UI widgets, whatever. Like if we break ABI, if we change the ABI for some platforms, for some implementation, like you're not going to be able to link against any of those things. This is fine for some people, but is a hassle and a frustration for a lot of users. Like from my perspective, having spent a lot of time thinking about like the role of C++ in the broader software ecosystem and software engineering practices and all of these things, like there was a talk that I gave at Pacific++ a couple years ago where the quote that everyone comes back to is, we need to be recompiling from source with the same compiler and the same flags, probably built at the same time, right? As much as you can, right? Because that's the only way that you're going to avoid ODR problems and subtle issues of ABI and all of these things, right? And if we actually did more of building stuff from source, then all of these problems would be much less like dire. But instead, we ship a lot of binaries and we have plug-in interfaces that go back 5 or 10 years, and like we're kind of stuck. And I think it's probably best for the ecosystem, for the committee to just admit, like, yeah, we're kind of stuck. We're not going to change this. We will do our best to not force everyone to recompile. That is an unfortunate step backwards. Like, I think if we had been clear about our priorities and mindful of this from the beginning, we might have made smaller changes, made more regular changes, made it easier to change. But at this point, I think the clock has run out. Like, I think it's best for us to admit that this is the state that we're in and try to work around it.
So I guess that wraps up our discussion on IB-related questions, at least for now. Let's switch to Upsale library, because there are some questions.
Oh, can I jump in with a question, with a very quick question about the name of the library? Because I've translated it to Russian and I don't know the Russian word. I looked up the word in the English dictionary and it's somewhat strange for a C++ library.
Yes. There were a bunch of people on the team that were into rock climbing when the team was forming, and abseil is another word for rappel, like you're slowly going down in a controlled fashion in a harness with a rope. There are a number of other stories about where the name maybe comes from, but I think that's the easiest one. I kind of actually like the argument that it is also the opposite of boost, in that boost, like rocket boosting, is being on top of a thing that's just exploding, and I hope that sugar goes out okay, whereas this is a very controlled doing the opposite. And I have no bones, like I have nothing bad to say about boost. It has just a very different set of priorities, right? Boost is very good for what is the absolute wildest, furthest frontier of stuff that would be neat to see in the language. And that's very valuable. But in order to achieve that, Boost very explicitly has policies of like, we're not going to promise that one version is compatible with the previous in any way. Like, if you try to upgrade Boost, you may have to do significant source changes, right? And certainly you're not going to have binary compatibility, right? Abseil tries to be somewhere between Boost and the standard library, and like, we aren't going to force you to make source changes unless we can automate it for you, right? We are certainly not going to promise binary compatibility. We change those things all the time. And then we do stuff like adding in the hash randomization so that we maintain the ability to change like representation and traversal and layout and hash functions and all of these things without people having Hiram's law dependencies on how it happened to be before. I kind of like the abseil as the opposite of boost, but
that's really cool. So basically, you answered our first question about the main idea behind Upsale library. Do many people outside of the Google use this library?
That's my problem with open source releases. Like, I can't tell. Like, I get reports on it on a fairly regular basis. I know that like people at least poke at it for academic purposes, checking benchmarks against hash tables, things like that. Like we do have a steady stream of user reports of things that worked or didn't work, but I have no idea how to translate that into like user population base. That said, like we were never chartered to like my organization at Google never said, hey, and go out and make this the most popular open source C++ library. Like that's never the goal. The goal has always been we need to have the ability to share code between how we do things internally and the rest of the world. And so a lot of Abseil's value for Google's purposes is when that becomes the infrastructure that's being used by other Google open source projects. Chromium depends on Google on Abseil now. And And it also gives us the ability to like hand some of the like very fiddly and computationally important pieces. We can hand, hey, here's our Mutex implementation to IBM to be like, hey, make sure that in your next generation of chips, or Intel rather, make sure in your next generation of chips like that this works smoothly. Having all of those things out in the public has some benefits.
Cool. We can discuss with Anastasia Kazakova. Maybe JetBrains will include Upsail in their. Oh, do they ask about this library? I don't remember. So it will be really interesting too.
Yeah.
Do you think the library contributes to adopting the new language features?
Say that again?
Do you think that the library contributes to better adopting of new language features?
Yes and no. There's because we have external projects and external Google projects that we care about that have language version support for their users in C++ 11, even though our internal code base is almost entirely C++ 17 at this point. Having our own versions of the more modern interfaces gives us the ability to sort of fall back gracefully when we're trying to interoperate in environments that are outside of our norm. And so we see this with the original set of like C++ 17 library primitives for optional and variant. But we also see it for things that are coming in like C++ 20 with source location, for instance. So we have things that are trying to mimic the source location interface and that are digging into the compiler intrinsics that are behind source location in compiler versions where those exist, and that they try to fall back gracefully, on platforms where that doesn't work, either by, giving you less information or providing macros that sort of synthesize the same thing. So in some respects, it's having one place to find interfaces that will become standard in the future, and so there is some value in those sorts of things. And we have.
Is there any other value of using the library in modern C++ dialects, like C++ 17?
I certainly
Except
think so. I certainly think so. Like hash tables are, highly optimized, significantly better. There's, a lot of production smarts that have gone into things like the command line flags interfaces. Google has a sort of over aggressive addiction to command line flags for its production jobs. Like there's kind of too much of that, but it does mean that we've had to learn some things the hard way. And so there's features in the command line flags interface for and here is a feature so that if you encounter this flag when you're parsing the command line, that's okay, but the flag doesn't actually exist in your source code. And so this is a way that you can roll out changes to the set of command line flags for a binary or for a library this is how you retire, this is how you deprecate a flag. And that is a feature that you just don't have until you've had problems with executing that change, for years. So, depends. The flags stuff has a lot of value in it. Google's sort of standard mechanism for reporting back errors without exceptions is present in there. We are continuing to work on an update for all of our logging libraries, things like that. And then our strings handling is vastly better than anything else that I've seen, particularly stircat and stirjoin and split and things like that. Whether or not you prefer the Abseil formatting library versus FMT out of C++20, that is a matter of taste. But like the string routines and
Are there any benchmarks?
Yes.
Sorry.
Many.
Okay.
Yes, many. But benchmarking is an art. Like benchmarking is, I cannot tell you how many times people ask questions in Stack Overflow or internal mailing lists for C++ questions, and they're like, "Why does my benchmark show that none of this matters?" And like C++ has the as-if rule, and it is pretty easy for the optimizer to prove, "Oh, you just did the same thing in a loop a million times. Well, I'm just gonna skip that. Like you didn't do anything with those results. It doesn't matter." We get questions that boil down to that pretty regularly. And the problem with micro benchmarks in particular, like one, you have to have a decent microbench framework, which there are some. That's fine. That's doable. But yeah, also have to make sure that the benchmark that you're producing is representative and meaningful. Like for hash tables, it's very easy to have benchmark results that are highly misleading depending on the state of your cache. And so like one of the things that the hash table benchmarks does, for instance, is there is a separate set of benchmarks for hot cache and cold cache. In the hot cache benchmarks, we have relatively small tables that are going to fit in cache, and we like warm them up. And then for cold cache benchmarks, we have many, 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 many tables, and we do the operations on them in a round robin fashion so that nothing is ever in cache, which is probably a little bit more extreme than what you would get in a like live production environment, but is more representative than a simplistic micro benchmark would be. Like benchmarking is full of gotchas and requires a lot more depth than people seem to naively understand.
Thank you.
So, is it okay if we switch to your book, Lessons Learned from Programming? So, as far as I understand, this book stated as a collection of recipes used in Google. Do you think, how universal are they? Does it make sense for others to learn from them?
So I hope so. I've tried to make it very, very clear, like the book is the way that Google does things and our reasoning and why we think that those things make sense. But we are not going to say that, like, in no place in the book, unless I miss something, is it saying like, this is the one true right answer, and if you do it some other way, you're wrong, right? Because it's complicated. One of the things I say, the author of Accelerate, which is another tech book that I respect tons, Nicole Forsgren, I was talking with her, and she said, accountants are mentioned in the Bible, and they are still discussing accountant best practices. Software engineering is just over 50 years old, right? It's going to take us a little while to figure it out. And I think that's really important context. And Google has had experience at scale and with timeframes that most organizations, aren't going to get to maybe ever, and certainly aren't going to get to for a while. And so I try to portray this not as, hey, here's the answer, do it this way, but instead to focus on, this is our scouting report. Like, we have seen what happens at intense scale and with 10, 20 years experience in the same code base. Like, if what we have learned is useful for you, great. And if not, I'd love to hear your reasoning. But everyone's going to do something slightly different because our use case is not universal. We are still pretty highly focused on building and deploying web services in production, and that is going to be a little different than a lot of other people's workloads.
Cool, thank you.
Can you tell what's the best thing that you personally learned from programming, working as a programmer in Google?
It's not at all unique because I've heard it from many other engineers. But the more experience that I get, and the longer that I'm, functioning as a programmer here, the more that I am convinced that most of what problems we have are communication problems, not technical problems. Like convincing someone, oh, this is why this is the right answer, is often more important than just having the right answer. And increasingly, I'm much more worried about factoring in, if we're wrong, how expensive will it be to fix this into our decision making? If it's an important decision, but also easy to change our minds, it's not really worth all of that much worry and anxiety. Whereas if it's a only sort of important decision that we'll never be able to undo, I'm actually going to spend more time thinking about that. So, planning for change. That's
really interesting.
And then as far as lesson from the book in particular, the first chapter that I read that someone outside of the leadership team for the book, the first chapter that I read that really blew my mind was the one on build systems, and just conceptualizing the march of build systems in complexity, and drawing the parallels between that and programming language paradigms, and then realizing it has always been amazing to me internally at Google. Wow, build is just amazing. We have all this caching and parallelism, and it's distributed, easy, just always works. I've never run make clean. It just doesn't matter. And having someone actually sit down and explain why that works and what properties your build system should have in order to get that, that blew my mind. So that's always going to be one of my favorite lessons taken away.
Cool, thanks. So I guess most of the tooling that exists for C++ is not working for Google because of the scale, probably. So does Google use some of the external tools, besides of
Which
compilers
tools?
And stuff? Well,
what tools are
whatever you use for your code, starting from compiler, static analyzers, sanitizers, whatever.
I mean, yes, we use all of those things. Most of our tool chain at this point is Clang stuff. For compilation, it's Clang LVM. We have a lot of static analysis in Clang Tidy.
But is it internal? Is it internal product, or is it open sourced?
Most of it is open sourced. We tend, there's some specific Clang Tidy checks that don't apply to the rest of the world. They're based on internal interfaces, things like that. So those checks we have, kept inside, and so we have a slightly different build of Clang Tidy, but it's not functionally all that different. Sanitizers is a huge deal. I have a suspicion that we use sanitizers more than most. And that actually, again, goes back to ABI, because if all of the things that you're linking against aren't billed with sanitizer mode, then they either don't work or it doesn't help. Whereas we internally at Google have a you should build it from source model for basically everything. And so it's very easy for us to spin up a sanitizer build of any given problem and then poof, magic. Now you know where the bug is. It's all connected.
Oh, thank you. I've got a question about what do you think about some kind of a certified CPP courses, or maybe some means of education, and the courses might be approved by the committee. A CPP book, for example. The whole industry will benefit from that.
All of my graduate work was in computer science education, so I'm very sympathetic to like educational problems. I'm not sure. I mean, similar to the committee's relationship with ABI, like technically the committee's job is to publish a spec. Like everything else is sort of outside of their purview, formally speaking. But a lot of committee people are writing books. Nico has C++ 17 book already, and Bjarne's tour of C++ is still important. There is increasing amount of work being done in the committee to come up with curriculum guidelines and like sort of best practices, because there is a big gap between the C++ a lot of schools are teaching and like actually modern C++. I think a lot of academic instructors have not caught up to the fact that C++ is moving quickly. I think that there's room for a lot of benefit in having more focus on education and best practices. I'm not sure whether or not that needs to come from the committee, but having more committee people like endorse it will certainly like help give that some credibility. And it's very important. It's also very hard to prove that it mattered. This is one of the things that I run into pretty regularly. Like my teams publish the tip of the week series internally, and we try to externalize those on ABSILE.io. And those are cited a lot. Those are read a lot. I have a staggering number of page views. I can't prove that any of it necessarily prevented a bug. Like you can argue that almost certainly did, and almost certainly like made development times faster and higher development quality. But it's very hard to prove the outcome that didn't happen. And so, yeah, it's a very complicated topic.
But
Sure.
they have inside in Google some kind of crash course for people who want to start C++. For instance, some people switch from Python sometimes,
Right. We kind of don't. We have a lot of things for at least the basics of the language, but we've never really invested in like some other language, but you don't know C++. Let's teach you C++. Some of the people that work for me have been sort of tinkering with curriculum along those lines, but we haven't really found time to focus on that a ton. And I think that's a little unfortunate too, specifically because like in the talk that Chandler and I gave at CPPCon last year on like what is C++, I think it is really important to have a fairly deep mental model for like what the language is actually doing, because it is so different than many other languages. It is very like there are many surprises in here. This is a language that has false positives on the question of, is this a program? And this throws off everybody's reasoning, right? Like I get daily questions of the form like, I did this and it worked, and I did this and it didn't work, and those don't make any sense together. And the way that they make sense is when you go back and you say, well, the thing that you said worked, it's only it happened to work. It's not actually correct. It could have done anything. It just happened to do the thing that you hoped for, right? And like that is learning to reason about how C++ actually works is a really hard skill that I don't think we're doing a good job of like disseminating that. And so I think there's a lot of room for people that really understand those details going back and trying to do some like intro curriculum, try to like ease people into it. Like, what is the object model? Like, what's the difference between a value and a reference? Like, what's memory? And also, just for the record, this language doesn't behave the way you think every other language does.
Didn't committee started some kind of subgroup on education recently? Or
Yes.
it's just my dream?
And no, they did. And they are mostly focused on like sort of identifying topics that they would endorse having in a college curriculum, and trying to focus on things that should be taught and maybe the order that they should be taught, and like but it's still kind of early days. There's a lot of work there and a lot of opinions.
Oh, thank you.
So regarding committee, yeah, thanks. Yeah.
Another
Sergey,
question about the relations between Google and the standards committee. Is Google's investment into committee's work is big? Does it? Well, I'm trying to translate from Russian.
Sure.
Does it sponsor some activities besides the committee meetings? For example, does Google sponsor programmers for writing papers or stuff like that?
Yeah, for a lot of us that are participating, like there is a C++ organization inside Google that's probably somewhere around 100 people, between Google's people and compiler people and library people. Like my branch of the world is mostly library people, and it's like 30, 35 people. Some of them pay attention to standard, some of them don't. Which is fine. So when we have, proposals and questions and things that need to be resolved, it's been our policy for a long time now to have at least one Googler fairly active in at least the big important subcommittees. So we'll have someone sitting on core and someone in evolution, someone in library evolution, someone in library, someone in SG1 for concurrency. And then beyond that, it's a little ad hoc. But this means that like for those people who were considering it part of their core job to be involved in those things, writing papers, reviewing things, all of that, like is very much considered sort of inbounds for their Google paycheck.
More interesting. Yeah, I think so. Do you think if some companies will invest more into sending people, like smart people, to a committee, C++ will evolve faster and better?
I don't know. Like, I'm not sure that the evolution is currently gated on the amount of work that people can do or the amount of smart people in the room. Like committee meetings are, 150, 200 people these days, when we're not in a pandemic. Like there's a lot of work there. It is sort of a matter of committee work is a lot of investment and very long payoff times. And I've heard from other big companies and people working at other big companies that like going to committee and trying to solve a problem like correctly, deeply, once and for all, and get that into the standard, that is a ton of work, a little bit of politics to like get all the details worked out and get the votes to actually get it pushed through, and then isn't actually going to help your company for another 1, 3, 5 years until those things are in the standard, actually implemented and widely deployable. And that's unfortunately a really kind of hard like investment argument, and so it sort of goes back to where I stand on the ABI question. Like I think a lot of groups are going to have their own like internal batch for utilities and do their work there because it's easier, it has a quicker payoff, and that actually fits with sort of the original committee model of standardizing existing practice. Whereas I think a lot of fairly novel things are going into the committee these days.
Okay, thank you. And on slightly different topic, there's a question again from chat. I have the modules from C++ 20. Will they solve some issues in Google code base or something?
We started, this is really not my domain. This is very much a Chandler question, but we started worrying about compile times, pretty heavily, just looking at graphs quite a few years ago of like, what is how many translation units are going into every build? What is the compute time for every translation unit, right? And all of these things are growing in kind of awkward fashion. And part of the reason that they're growing is because without a module system, C++ is reliant on the textual inclusion capabilities of C from the 1970s, right? And this, if you look at the graph of it all, clearly there's a sort of quadratic growth implied just in, we're just going to recursively expand the text of all of these files and then, feed it back through the parser. At some point in your growth, that's going to be a problem. And so we started investing in modules, as a mechanism to be able to draw some lines in those transitive inclusion, chains, so that there's something that's actually technically correct that can impact build times. The modules discussion is very detailed and very language centric and very tool centric, and those are specifically the areas that I'm not expert. For library questions, yep, that's me. For compilation questions, it's not quite my department. So I think that's okay. Most of the depth that I actually have on that topic.
Okay. So I think we still can at least discuss one more question. We 5 minutes.
We've got 4 more minutes.
4, yeah. Sergey, will you?
Oh, well, the last question we've got is quite big. I don't think we will have enough time to discuss it in 4 minutes.
It's actually, I can reformulate it. So it's regarding Clang Tidy. So the question is, do you think that major user of Clang Tidy is this corporations like Google, Microsoft, or someone else, based on the list of people of the contributors? So do you think there are some other companies invest in some other tools?
So I think it's important to separate who's using it from who's contributing. And like, I know that there are lots and lots and lots of users, from all walks of life, all types of development. The question of who's contributing is a slightly different question. And I am not at all surprised if you tell me that it's mostly big company people. Because as it turns out, doing proper, like actually reliable static analysis with relatively low false positives is not easy. Like the C++ is a very, very complicated language, and like doing analysis, doing rewrites, automatically in a language that has macros and templates and all of these other things, like there are a lot of details in there that are going to be a lot of effort to actually get up to a like production level of quality. It's not just a 2-week undergraduate project, right? Like you're gonna actually have to put in a lot of hours on that. And so it's not surprising to me that it's primarily big companies that are investing in that, because you're gonna have one person spend, I don't know, 100 hours on a thing, right? You're going to have a very large user base for that to pay off. You only have 10 developers. It's going to take you a lot of years for a 100-hour investment to actually pay off. Whereas if you have 12,000 developers in C++, then the math is a little easier. So.
Okay, thank you.
Yep.
So, guys, thank you for such a diverse discussion on different topics. Really broad look at the C++ events and happenings. So, really pleased to hear all that, and nice, pleasant talk around. So, we're finishing. It's time to move to a Zoom conference after that. So I'm gonna say bye and close the day. And so see you in Zoom.